So question 3 asks, in the circuit of figure 3, VI is a triangular wave at 10 volts peak whose frequency is to be measured by a system that requires its inputs to lie within the range 0 to 3.3 volts. If damage to the system is to be avoided, assuming the diodes have forward bias voltage drops of 0.7 volts, choose values for V1 and V2 that will clip those parts of the triangular VI that are higher in voltage than 3.3 volts and lower in voltage than 0 volts. So, the circuit of figure 3 looks like this. So this is just another way of drawing a triangular source, and the only reason I changed it from the usual symbol I use is to differentiate it from these battery type sources which represent fixed voltages. So we need to figure out, or we need to decide when the diodes will be conducting. Sorry, that's a killer ohm. So we'll draw a graph as usual. And we'll have time, and we'll probably end up with the V out, and we're going to have some V in, and our V in will be like this. It isn't entirely necessary to draw a graph for this, but we will anyway, just so we can see what's going on. And we know what we want to happen to V out, because the question tells us we've got to make sure that the input signals to the system that does the measurement lie between 0 and 3.3 volts. So our output, our V out, has to look like this. Oops, sorry, that's not quite right. 3.3. We'll put 3.3 at just here. So we've decided what the shape of our output voltage is going to look like, and now we need to make a decision about which diode is going to be conducting for the part up here and the part down here, because the diode conduction is going to drop some voltage across this resistor by virtue of the current that flows through it, and that is what's going to allow us to limit V out from the range of V in. We'll be dropping all the voltage we don't want across the 1K resistor. So if VIS, if we deal with this, the region of negative voltage first, if the voltage is negative, that means that there'll be this will be the sort of the more positive end, and this will be the more negative end. So if that's going to be the more negative end, we'll end up with a voltage like that, and that will be causing a current to flow like that, and this current's going to flow, it could go around there and up there, it could go around there and up there, assuming one of these diodes is conducting. But if the current is trying to go that way, this diode would have to be reverse biased in order to make some attempt at conduction of this current. It wouldn't, because the diode, it won't conduct any current if it's reverse biased. But current flowing in a diode, you've got your diode like that, and the voltage is across there, and the current is down there. Well, this current would not be the right way. It's trying to go that way, which is not the case. So we know that this diode here doesn't deal with this bit here. So it must be this one. And we can say, well, there's a current that goes up there. So for the voltage around the voltage arrow, we can, or around the voltage source, we can draw like that. And the voltage across the diode be like that. Sorry, it's faded. And we know that to put this diode on the edge of conduction, we'll need 0.7 volts across it. And we know that in the situation for our output is that we can't have any less than 0. Sorry, that's 0 there. So we can't have any less than 0. We know that this must be 0 volts with respect to our reference, and that under the peak conditions there'll be 5 volts across our resistor. So what do we need to do? Because our reference is at 0 as well. This is all 0, and it's just that this is at minus something. At the most maximum cases, at minus 5. So if I've got 0 there and 0 there, and I've got to get 0.7 volts across my diode to put it on the point of conduction, then this voltage must equal this voltage, because otherwise I've got 0 plus 0.7 minus 0.7 equals 0. So for my voltage source voltage, it's going to have to be 0.7 volts. In order that the diode will be switched on the point of conduction as soon as the voltage drops to 0, and conduction current will begin immediately. If we made that 0 volts, then we'd have a 0.7 volt offset, and our output would fall to minus 0.7 before the diode started to conduct. So similar arguments apply to the other diode. We've got to get 0.7 volts across here somehow. When that's now changed direction. And the direction of current's changed as well. So this is going to be 3.3, and current now goes that way up. So the current's going to go up there, round there, down there, down there, round there. So what do we have to do? Well, this is going to be at 3.3 volt, sorry, wrong car. This is going to be at 3.3 volts. That's going to have to be at 0.7, and the current that flows through here is going to be 0 amps, because we're on the edge of conduction. So what do I have to do to this to manufacture 3.3 here, given that I've got an extra 0.7 involved? That's 3.3 minus 0.7 on that source there, because we'll have 3.3 less 0.7 plus 0.7 gives us 3.3, which is the point at which the diode needs to be on the edge of conduction, so that current conduction will start, and will start dropping the voltage across the resistor. And as a result of the voltage dropped across the resistor, the input can keep rising in this region, but the output will be clamped. So that will be 2.6 volts. And this one is 0.7.